Welcome to the Loci house. I'm back with the Unity shader graph tutorial. Today we are diving into 7 key adjustment nodes that can help you manipulate and refine colors in your shader. We will explore how they work, the math behind them, and some useful tips to get the most out of each node. Let's get started. The channel mixer node. This node lets you ramp up the red, green, and blue channel of the image or a texture. Think of it as a mixing desk for the colors. You can influence a percentage of each channels to another. Let's look at the maths behind it. For input, we have vector 3, which represent the pixels 3 channels R, G, and B. So for input and output, we will annotate like this, and the calculation will happen something like this. This calculation will be done for each channel. If you observe the channel mixer node, we have three inputs, three output, and there is a three channel buttons to select from, and these three sliders represent these three constants which will influence the red channel only. The both equation looks the same, but they both calculate different values. Its match shows that you can increase the influence of the one channel to another by simply manipulating the coefficient into the another channel. If there is a pixel with a red 0.7, green 0.2, and the blue 0.1, then we can influence the green based on the red by manipulating the out green channel's red handle. So while calculating green output, we can simply put red influence by increasing the coefficient to 0.5. So let's look at it into the example. So let's see what happened when I increase the green's red channel. As you can see, red will become more like a yellow because you are increasing the amount of red into the green channel, not in the red channel. So what is happening right now, when they are calculating the green channel, wherever there is a red portion, they are increasing the amount of green into that portion. So the green and the red mix up and become a yellow. Use this node to create a custom color effect like simulating grayscale by averaging the channels or creating a unique tint based on the color or texture. The contrast node adjusts the contrast of the texture by emphasizing the difference between the light and dark areas. For contrast, it will process each pixel for all three channels, and all of these values are between 0 to 1. If your channel value is above 0.5, then it will increase it, and for below 0.5 it will decrease. Now let's look at the math so you can think clearly. So for input we have vector 3, and for output it is the same. If there is a more or less channel over here, it will do the same. Its calculation won't be changed. So we are representing each channel over here by C. The equation is really simple. You first need to subtract it by -5 and then multiply it by our constant, which is input, and then we will add 0.5 into it. Now you might be say that why subtract and add, because if the value is above 0.5 it will increase, and if the below it then it will decrease. So if you are making your own node, you can also add 0.5 as a threshold value. Let me calculate it for the two different values, which is 0.4 and 0.6. Amount which is below 0.5 will decrease, and the amount which is above 0.5 will increase. It's a really simple math. So if I decrease the contrast, it means the all colors are fading out, and doing it too much will result into loss of light colors. Be cautious of the high contrast values, as it can cause a clipping where details in the shadows and the highlights get lost. Some of the games like Lost in the Random and the Bioshocks are the perfect example of the great high contrast games. Next up is a Hue node. The Hue node rotates the hue of the texture around the color wheel, essentially shifting the perceived color. The math is really simple. we are just adding the shift to the existing hue. Little tip is to combine this node with the saturation and contrast node for advanced level color grading. A rhythm puzzle game that frequently shift the hue to match the tempo and the mood of the game is a great place to use this node. The invert color node. The invert color node simply inverts the each color channel, turning black into white, red into cyan, and so on. Maths for this node is also simple. Our all channels are between 0 to 1. So to invert it, we just need to subtract it from the 1. So the value 0.4 becomes the 0.6 and the zero point 0.8 becomes the zero point 0.2. This node is a great for creating a negative effect or enhancing the certain details by flipping their colors. Also can be used into the horror games flashing effect. Sudden color inversion can enhance the jump scares. The replacement color node swaps the one color range for another defined by the target color and the range of tolerance. Maths simply calculate the tolerance level of the pixel. If the tolerance level is higher than our range, then pixel color will be replaced by the target color. So basically this node simply calculates the distance between the current RGB of the pixel to the target RGB. So let's look at small example into the node where I replace the green color with the purple. If I reduce the range, it have a lower effect on the color replacement. As I increase the range, it will cover everything. Always experiment with the tolerance to ensure the smooth transition when the replacing the similar shades. Plantus does not use the unity, but the similar mechanics could be implemented where the area or object changes color dynamically in the response to the player actions. The saturation node. The saturation node controls the intensity of the colors in your texture, making them more vivid or muted. Thinking of a saturation means the converting image to the grayscale. So converting to grayscale means for human eyes it should look black and white, but for other animals it is different. For the calculation of luminance, we have a three constant based on the normal human eye. So this is the calculation for luminance, and if we want to use this in our channel, we need to do channel out is equal to luminance plus channel in minus luminance into saturation, which is over here. Little bit increased contrast and saturation will act as a salt in your game visuals. The white balance node. This node adjusts the color temperature and the tint, simulating warmer and cooler lighting conditions. In temperature shift, we increase the red and reduce the blue into the pixel, and green will be the same. In tint shift, we are increasing green and reducing red. Blue will be the same. It adjusts the RGB channel based on the user defined temperature and tilt. Exact calculations are often empirical and may have follow the color temperature correction curve. Use this node to simulate the natural lighting effect or to correct unwanted color cast. That's it for the adjustment node into the Unity shader graph. Whether you are creating a stylized visual or realistic lighting, this node gives you fine control over colors in your shaders. If you found this tutorial helpful, like, comment and subscribe, and let me know which nodes I should cover the next. See you in the next video.